The year was 1958, and times were fine. The Korean police action was history. A kid named Mantle was having the time of his life in New York, and that young senator from up Massachusetts way was sounding, well, presidential. As the year turned, rock and roll was on every jukebox in the country, and exposure was the name of the game. Get out on the road. Let the fans get to know you. One cold, snowy February night, three of rock and roll's biggest stars, Ritchie Valens, J.P. Richardson, known as the Big Bopper, and Buddy Holly chartered a flight from Mason City, Iowa, so they could avoid the long, cold drive to Fargo, North Dakota. Shortly after takeoff, the pilot radioed that he was icing up and losing power. It was their last message. There were no survivors. They called it the day the music died. Would that same accident have happened today? Well, no one can say for sure. But on a nasty fall evening in 1994, an ATR-72 crashed into this field of withering soybeans near Roselawn, Indiana, killing 4 crew members and 64 passengers. The NTSB concluded that icing was the cause of the accident.
We just finished our sounding over the Lorain County Airport. Cloud liquid water content's pretty low. We're getting about 0.2 grams per cubic meter. Clouds are pretty shallow with tops topping out at about 6,000 feet.
Okay, looking at the weather, clouds are pretty solid, but your best bet is to go southwest.
The FAA's Aviation Weather Research Program asked the National Center for Atmospheric Research to work the problem. There, scientists speculated that if the conditions that caused in-flight icing could be identified and forecast, the threat could be reduced. Dr. Marcia Politovich is the leader of the research team.
We started out with using information from single sources, a satellite, a radar, surface observations, models. Each of those gives you a clue as to where icing is or is not, but taken separately, none of them tells you everything you need to know about the icing environment, where to go to get into it, as we do as researchers, and where to stay out of it, as the operational forecasters do. It's very human intensive to do that, and it's a difficult problem, as the people at the Aviation Weather Center who do this every day, day in, day out, will tell you. It seems natural to automate the process, and the result is our integrated icing diagnosis algorithm, or IDA, and its counterpart, IFA, where the F stands for forecasting. As a user, this is where you would introduce yourself to come in to the display. This is a composite of all levels, kind of squished together to show you the most likely icing you'll find at any altitude. Now this shows a different view of the same information we just saw. This is a vertical cross-section. This shows icing in the Milwaukee to Denver cross-section. Near Milwaukee, over to about Omaha, we have icing conditions likely to about 15,000 feet, and very high likelihood there at about around 5,000 feet. This new product will impact all sectors of aviation, but primarily those which fly at icing altitudes, something like 18,000 feet and lower. Those altitudes are more conducive to icing conditions. The larger air carriers, such as those you'd fly across country, tend to go through those altitudes quickly, and they cruise at much higher altitudes than you're likely to find icing. It's the commuter airlines and the smaller general aviation type airplanes that tend to linger at those altitudes and pick up icing where it's present.
One of these regional carriers, SkyWest Airlines, participated in the verification phase of the development of IDA. Captain Mike Finch liked the result.
As far as reliability goes, I found it to be extremely reliable. I would take the printout with me. When I'd climb out at the various levels, I'd see exactly within 1,000 feet where the icing would begin, how long I could expect it to last. the severity of the icing at different levels and different points along the route. I'm really impressed. Excellent product. I do use it, and again, I can't say it enough. It's just remarkably accurate. I can't believe, when I pull it up on the screen and then I go fly, it's right where it says it's going to be.
In-flight icing isn't the only winter weather problem that plagues aviation. When a major snowstorm hits any of America's major airports, it can throw the entire air traffic system out of sync. A new system, dubbed Wisdom, for weather support to de-icing decision-making, has been developed by the NCAR scientists for the Aviation Weather Research Program. Wisdom lets decision-makers anticipate the onset and termination of snow so that aircraft de-icing can be coordinated, runway treatment and plowing can be scheduled, and so controllers can better manage the impact of the snow on air traffic. John Farley is a duty manager at JFK. He's found that Wisdom is a real asset when snow is on the way.
This New Year's 2001 was a weekend holiday. We had a major snowstorm which dumped over 10 inches here at JFK, and we made our preparations on that Friday. We came on at 2300 that night, checked the weather forecast, and they said 6 a.m. local time for the storm to start. Wisdom, halfway through the night, told us otherwise. So it was around 2:30 in the morning when we realized from Wisdom that the storm was rapidly approaching. Checking the surrounding airports on the Wisdom system confirmed that at Atlantic City and Newark Airport. So we were out with the de-icing chemicals by 3:15 and completed it by 4 a.m., all runways and taxiways. And in fact, the snow had started by that time. By 5 o'clock we had 1 inch, and like I said, eventually we had over 10.5 inches here at JFK, which really paid off several days later when we went to remove the snow. We got it down to bare pavement with no problem at all because the de-icing chemical was able to prevent the bonding of the snow and ice to the pavement.
Weather can challenge aviation in many ways. For instance, in 1997, the eastern United States was battered by a severe turbulence outbreak for 3 days. Jim Henderson is the deputy director of NOAA's Aviation Weather Center. He remembers that incident very well.
The outbreak occurred from the Great Lakes area across the Ohio Valley into the northeastern U.S. and down to the mid-Atlantic states. Quite a few reports, several hundred in fact, of severe and moderate to severe turbulence, as well as some extreme reports. Some of the reports we got were from 737 captains who said it was like hitting a wall. I lost control of my aircraft. Everything went flying, hit the windshield. I mean, when you see those kind of reports from experienced commercial captains flying these large aircraft, you know that's a big daddy of an outbreak.
Occurrences of this severity are rare, but thunderstorm activity resulting in turbulence, wind shear, or heavy rain is an everyday problem. Convective weather can result in chaos for flight schedules and is probably the major cause of weather-induced airport delays. A new tool is now available to forecast convective weather activity. MIT Lincoln Laboratories' Dr. Marilyn Wolfson looks at the project's progress and goals.
I'm Marilyn Wolfson, and I'm the lead of the FAA Aviation Weather Research Product Development Team here at MIT Lincoln Laboratory. We're doing research to predict thunderstorms that can cause trouble for aviation, that it can impact air traffic, that can cause delay, and that are a safety hazard. When you try to make forecasts 2 to 6 hours ahead, which is what you need to do flight planning around the country, if you're flying from New York to San Francisco or Dallas to Chicago, you know, they would like 90 minutes lead time before the flight even begins. So the look ahead for weather forecast is available, but that's imprecise, and we know it's going to be wrong, and we know it's going to change. How do we deal with that? It's actually been a very difficult problem for radar meteorologists. We don't actually want to track the cells within the storms. We want to track the whole envelope of the storms. And we've come up with a breakthrough in this area. And we've used that technology in 2 systems, the National Convective Weather Forecast and the Terminal Convective Weather Forecast. Now, the National Convective Weather Forecast gives you some past weather and then a contour of the 1 hour forecast overlaid on the current weather. It doesn't show any small storms. It just shows where the large elements are going to be 1 hour in the future. The Terminal Convective Weather Forecast shows everything that's level 3 and above that could affect aviation, and it integrates that forward so that you have an animated loop forecast out to an hour in 10-minute increments. What we're trying to do with these products, first of all, is to deliver and make operational what we know is already a useful product, which is the 1 hour forecast. I think that there's a tendency for research teams to wait and to put their the fruits of their labor out there for operational use until it's perfect. We don't want to do that. We know this is an operational capability that's extremely useful. We're going to put that out there and make it part of FAA operational systems today. I think in the short term, within the next 5 years, we'll have a very accurate 2 hour forecast out there. I mean, we're really at a point where the technology for forecasting thunderstorms, for building expert systems, for getting the technology into the field is really there.
The threat posed by severe turbulence encounters make them something that pilots are taught to avoid. But avoiding turbulence is sometimes easier said than done. One form of turbulence, clear air turbulence, or CAT for short, can occur when it is least expected because there are no visual cues. Noreen Cohen is a representative of the Association of Flight Attendants. She's seen the result of a CAT encounter.
The worst turbulence accident that I was ever involved with was when I was called to meet a flight. I have been for quite a while a safety representative for the Association of Flight Attendants. And we knew that it was a wide body. We knew that there were some flight attendant injuries, some passenger injuries. We found out that every flight attendant was injured. 2 went to the hospital in ambulances. The rest of them went to the medical department to be treated. At the back of the plane, there were unconscious and bleeding passengers. One thing I noticed when I was looking around, we have some metal tie-downs that come out of the carpet, and we place the carts over them. They lock on these metal tie-downs. And the tie-down was all bent out of shape where the cart had been ripped right off the tie-down.
Again, the Aviation Weather Research Program turned to NCAR for an answer, this time in collaboration with NOAA's Forecast Systems Laboratory. They were asked to develop a forecasting system for clear air turbulence. NCAR's Dr. Bob Sharman is the research lead on the project.
Well, right now the only information we have about turbulence that is a real observation of turbulence in the atmosphere is pilot reports. Unfortunately, pilot reports aren't always that precise in terms of location and intensity. They tend to be a little aircraft specific because obviously a large aircraft doesn't bounce around as much for the same level of turbulence as a smaller aircraft. And also they're not automated, so that the pilot sends them when he can send them. We are about to start a new program which will replace the voice pilot reports with an automated system of measuring turbulence on commercial aircraft. The idea is to take software mounted on commercial aircraft. This software will automatically record the turbulence encounter, the timing, the location, the severity, and download that information to the ground so that people can have access to it on the ground, like researchers like us or the airline community, so that they can get a good, steady mapping of the three-dimensional structure of turbulence encounters in the atmosphere.
The user display for the turbulence forecast system, nicknamed ITFA, looks like this. The red and yellow shaded areas indicate a higher probability of turbulence, with a lessening likelihood in the blue and green areas. All of the best weather information in the world is absolutely useless, unless it gets to the people who need it, in a form that is easy to use.
Delta 1402, good afternoon, Atlanta Flight Control. Your dispatcher, Steve K. speaking, over.
Steve Case is a Delta Airlines dispatcher. He's been looking at a weather information delivery system that is a product of Aviation Weather Research. It's called ADS, the Aviation Digital Data Service.
I've examined the ADS product and I find that it contains among the best suite of weather products that I've found anywhere, either commercially or on the internet, and basically provides a one-stop shopping solution for airmen such as dispatchers to find the most relevant and pertinent weather information which might affect safety of flight. I'm talking about things like thunderstorms, icing, turbulence, and other factors that potentially could pose a threat to safety. One of the great things about the ADS site is that there are so many wonderful tools on there, and it's difficult to pick one that stands out, but I must say that the recently added flight planning flight path tool is an application that is unique among the products that I've found available to me as an aircraft dispatcher. If, as an example, I were working a flight en route from the west coast to the east coast and an aircraft were reporting turbulence to me, a very quick glance at this product would show me the aircraft's position with respect to the jet stream and give me guidance as to how I might reposition the aircraft's altitude to mitigate or avoid the turbulence altogether.
As Kay said, ADS provides a one-stop weather information center for flight crews, dispatchers, and general aviation users. In spite of these advances, weather remains the largest uncontrollable factor that affects aviation safety, efficient operations, and airport capacity. The FAA's Associate Administrator for Air Traffic Services, Steve Brown, has to cope with weather and its impact on air traffic on a daily basis.
Our forecast for growth in passenger demand and the number of flights in the national airspace system in the United States is that we'll reach about 1 billion passengers annually in this decade. As we add flights in our current system to handle that 1 billion passengers that are coming in the years ahead, it's essential that we address the largest factor involved in aviation delays and cancellations, and that's weather. While there will always be weather that pilots cannot fly through, there certainly will be weather that we can fly around more precisely than we can today, given better forecast products and more real-time observations. So for all of us in the system, whether it's managers, controllers, or pilots or dispatchers, we'd like to see weather products that give us not only better short-term forecasts, but real-time observations to minimize the deviations around weather, providing greater efficiency and greater capacity in the years ahead.
As Brown said, with domestic air traffic expected to nearly triple in the next 10 to 15 years, the need for the products of the Aviation Weather Research Program is both ongoing and urgent. Ongoing because of the many weather-related problems that still need attention, and urgent so that we will never have to remember another day the music died.